This is the third video in a series of examples that I'm working out with implicit differentiation. Now, in the first two videos, I worked each example very carefully, showing every step. I'm going to try, it's challenging for me to do this, but I'm going to try to not give a whole lot of extra steps here and instead just work through each example and explain what I'm doing. But if you need something broken up a little bit more, I'm going to encourage you to try video 1 and then video 2 in this short series of implicit differentiation. Remember, for an equation where I'm asked to solve for y prime, what I'm going to do is the derivative with respect to x of each of the terms. I prefer to write that out on the example. So when I write the equation, I write it out with a little extra space. You can see that I've modeled that for both of these examples. And then it's really easy to go back and fill in the derivative with respect to x. And I like to do that with a different color. So it would look like that. The derivative with respect to x of negative 3y squared is going to be negative 6 y to the 1 times y prime, because I'm going to chain. The derivative with respect to x of 5 is just 0, and the derivative with respect to x of 5x squared is going to be 10x. Next, I'm going to solve for y prime by dividing both sides by negative 6y. And I'll simplify, so I get y prime is 10 and 6 can both be divided by 2, so 5x over negative 3y. Number 9, the derivative with respect to x of 4, that's just 0 because the derivative of a constant is 0. The derivative with respect to x of x squared is going to be 2x. And then I'm going to have to be careful. The derivative with respect to x of y squared is going to be 2y times y prime. Remember to chain whenever the variable doesn't match up to what we're doing the derivative with respect to x of. Whenever they don't match up, then I've got to include this chain of y prime. To solve for y prime, I'm going to subtract 2x from both sides. So I get negative 2x equals 2y y prime. Divide both sides by 2y to get the y prime left, right? And so when I divide 2x by 2y, the 2's can divide out, and I'm just left with the opposite of x over y. Moving right along, number 10, the derivative with respect to x of x is going to be 1. The derivative with respect to x of y squared will be 2y y prime. The derivative with respect to x of negative 3y will be negative 3. And then don't forget to chain, so times y prime. And the derivative with respect to x of 4 is just 0. Derivative with respect to x is 1. Plus, here I've got a y, so I've got to be mindful of chaining. 2y times the chain y prime. Negative 3, and then chain that y prime, plus 0. I don't really have to write that, right? But the derivative with respect to x of a constant 4 is just 0. I don't have to show that, right? Next, I'm going to isolate the y primes. So to isolate the y primes, I could subtract 2y y prime from both sides. So I'm left with a 1 on this side. And then on the other side, I'm going to kill two birds with one stone here. Hope I don't mess it up. But I've got negative 3. And then when I do minus 2y y prime, pulling out that y prime would be negative 3 minus 2y. And so then when I want to solve for y prime, I can divide both sides by that You know what I'm going to do is I'm going to divide out a negative. I hope that's not too tricky. But this negative 3 minus 2y, it's the same as the opposite of this quantity, 2y plus 3. I've just factored out a negative 1, and then I rearranged it to put it in descending order. But the final answer then comes out to be that y prime is 1 divided by negative 3. Oh, see, I have to still do this to the other side, right? Divided by the opposite of 2y plus 3. And that's it. Number 11. Remember to do the derivative with respect to x of each term. That's the first step. Some of these terms will be really easy. The derivative with respect to x of negative 4y squared is going to be negative 8y, and then don't forget the chain y prime, minus the derivative of y, so that's just minus y prime, plus the derivative of 3, the derivative of a constant is just 0. Don't even have to write it. I could just throw it out, right? Equals the derivative of 4x squared, so that's 8x. I'm going to get rid of this clutter, that 0. And I could think of chaining here, right? There's nothing wrong with doing this, but the derivative with respect to x of x is just going to be 1. The derivative with respect to x is just 1. So I don't really have to write that because it's just 8x times 1. Solving for y prime, be mindful of how you're factoring out the y prime. If I factor out a, I haven't shown this step before, so let me show this just in case you've been watching these and you're just not sure what I'm doing here. When I factor out a y prime, what I'm doing is saying 8y prime divided by y prime leaves me with negative 8y. And then this negative y prime divided by y prime leaves me with negative 1. Not nothing, but y prime over y prime is 1, right? And that is going to be equal to 8x. So to solve for y prime, I'll divide both sides by this negative 8y minus 1. So y prime is 8x over negative 8y minus 1. And that's it. Moving on quickly to number 12. We're almost done here. 3 more examples. Number 12, if I do the derivative with respect to x of each piece. Oh, this one I can see already is going to be a little bit of a doozy, but the derivative with respect to x of 5x squared is just 10x. The derivative with respect to x of negative 4x cubed y cubed, I'm going to have to be mindful of chaining and also using this product rule. Same thing with the 3xy. The derivative with respect to x of 3xy, we've got to chain and also use that product rule. But we can do it, we'll just have to do it carefully. The derivative of 5x with respect to x is just a 10x. And here's where I'm going to use the product rule. I like to pull that negative 4 out, but you could also think of the negative 4 and the y, or the x cubed, as one of the terms. So let f be the negative 4x cubed and g be the y cubed. You could do that, or you could just pull that negative 4 out and make it a factor for this sum. I'm going to go ahead and do it that way, right? So f in this example, f is the x cubed, f prime is 3x squared, G is y cubed. G prime is 3y squared, don't forget to chain, times y prime. So when I apply the product rule, we have -4 times the quantity of f prime, 3x squared, times g, y cubed, plus f, which is the x cubed, times g prime, which is 3y squared y prime. Let's do the same thing for this 3xy. So we'd have -3 times, the derivative of y is y prime. Oh, wait, I'm sorry, I'm doing the formula in reverse. So let me do the f prime first, right? So, maybe I better write it out over here just in case anyone's not sure what I'm doing here. The f term is the x, and the g term, the second factor, is y. The derivative of x is 1. The derivative of y is y prime. So when I say f prime, that's the 1. I'll go ahead and write it. And g is y plus x times y prime. And that's it. And then I'm going to add to that the derivative of a constant, which is just 0. So you see it's not that bad, but I'm going to go carefully. I'm going to step carefully with my algebra, distribute this -4, -12x squared y cubed minus 12x cubed y squared y prime. Distribute the -3, -3y minus 3x y prime. Do you see what the next step is going to be? It'll be to solve for y prime. So to solve for y prime, I'm going to subtract -3y and -12x squared y cubed, or in other words, move them to the other side. When I move them to the other side, they become opposites, right? They become, let's see, this -12, oh, don't forget the x. Let me write that really neatly. So we already had a 10x. And from the other side, we're going to bring over a positive 12x squared y cubed and a positive 3y, because when they move over to the other side, they become the opposites, right? And on the right side, I'm going to be pulling out my y prime, and I've got y prime times -12x cubed y squared, and y prime times -3x, so minus 3x. Divide both sides by -12x cubed y squared minus 3x. And we've got our answer, because it looks like there's no common term no common factor that we could divide out of everything, right? So I could leave this 10x plus 12x squared y cubed plus 3y. It doesn't match up exactly to the numerator, or to the answer box here. The numerator isn't exact because it looks like the top is going to be the negative and the bottom is going to have all positives. So I can easily make that adjustment. And I'm also going to put these in descending order. So I'm going to just change everything to its opposite. So -12x squared y cubed, and then I'll put the x term first, and then the y term. Oh, it looks like in the answer they put the y first, but that's okay. And then the denominator will make them positive. It's equivalent. Sometimes algebra is just doing some manipulation, right? So when I manipulate those around, I can get that same answer. Let's do this next example here on the same page. When I do the derivative with respect to x of each term, the derivative of x cubed, that'll be easy. It's just 3x squared. The derivative of 5y squared plus 5 quantity squared is going to be a little bit different because I've got to first chain the squared term, but then I've got to go back and be mindful of chaining the y. So it's going to look like this. Two times that blob to the first power, because 2 minus 1, times the derivative of 5y squared. That's going to be 10y plus 0. I'm going to leave that 0 off. Times the derivative of y, which is y prime. When I go to solve for y prime, I'm going to divide both sides by this. 2 times the quantity of 5y squared plus 5 times 10y. But, you know, I'm going to need to simplify that at some point. Let me write it down below here so it can appear more neatly. When I distribute that, 10y times 2 times this quantity, 10y times 2 is 20y, 20y, let me do it in that steps. 20y times 5y squared plus 5. Five times 20, 100. Y times y squared is y cubed. 5 times 20 is 100. Y, and that'll do it. Sometimes you could leave it in this factored form too, but if you're looking to match up to the answer in the answer box, that's the one that'll work. One more example I'll do is the derivative of x to the 6 plus 3 and the cosine. So the derivative with respect to x of each of these pieces. Derivative of x to the 6 is 6x 5. The derivative of 3 is 0. Derivative of cosine is the opposite of sine, 3y cubed. But then I've got to do the derivative of 3y cubed, which is 9y squared. And then I've got to do the derivative of y, which is y prime. To finish this example off, I'm going to divide both sides by 9y squared times the opposite of sine, 3y squared. It's going to look like this. So the numerator is just this nice 6x to the 5th. The denominator, it's a little bit better form to pull that 9y squared up in front. So I'm going to say minus, that's this minus here, right? 9y squared times sine of 3y cubed, and that'll do it. I hope that you've found this example to be helpful, and if I'm leaving the last step here, by the way, the simplify, divide out by, it looks like 3 is a common factor if you want to find the answer in the answer box. But I hope you've found these examples helpful and that you're getting the practice you need to become your own expert at implicit differentiation.